In chapter 6, we're talking about factoring, and we have different techniques of factoring. It's kind of more of an art than a science. In the section 1, we talked about greatest common factor and looking for a common factor that you can pull out. We're always going to want to do that first. So whenever we go to a factoring problem, we're going to want to start with the greatest common factor. And sometimes there is one, sometimes there isn't. After that, we go to some other techniques. Now, we also talked about grouping in the last section in 6.1. So we're going to talk about a different technique here, and I'm titling this video FOIL because I wanted to review foiling. So foiling is when you have two binomials and you're going to multiply those out. And so we use this acronym FOIL, and it stands for first, meaning you're going x times x, which is x squared. So that's like the first term. And then you go x times 3, which is 3x. And we call that the O, the outer terms. So the two on the outside. And then you go 7 times x, in this case. Those are the inner terms, so that's the I. And then 7 times 3, which is 1, and that's the L. Those are the last term here and the last term here. Now, FOIL is just a matter of keeping track of what you're multiplying, but the terms in the first polynomial have to be multiplied by the terms in the second polynomial. And so you have to do those different combinations. Many times we have a binomial times a binomial, and that's when we can use FOIL, okay, that acronym. Other people learn the box method, and there might be another way of doing it, but you have to get the two binomials multiplied sometimes, okay, at times. So if you look at these terms, and I'm going to go over here and rewrite this. So I have an x squared, I have a 3x, I have a 7x, and I have a 21. Well, the 3x and the 7x, those are like terms, and those can be combined. So I get an x squared plus 10x plus 21. This is a trinomial because it has 3 terms. And it has a degree of 2. It's an x squared. That's the highest degree on the term. So we call it a quadratic polynomial, but that's okay. We don't have to worry about that right now. Anyway, we get this cute little trinomial. And that happens when we multiply a binomial times a binomial, or a lot of times that happens. We don't always get a trinomial, but in this case we do. And so that's what's happening here. When we want to factor, what we want to do is we want to go from a trinomial back to the binomial state. Okay, so it's like we're going to try to run FOIL backwards. All right. Now these first ones that we're going to be doing, it says factor. They give us the trinomial, and we're going to look then for certain things that will help us to get this factored into a binomial times a binomial. Okay, so first look at the last number, which is 24. I need two numbers then that multiply to be 24. Okay, so there's lots of combinations, you know, it could be 2 times 12 or 3 times 8. We don't know yet, but we want two numbers that multiply to be 24. Let's start with that. We'll take this one kind of slow. So it could be 1 times 24. Now I'm just looking at integer combinations, and right now I'm looking at just positive numbers, okay? Positive numbers that would multiply to be 24. 1 times 24, 2 times 12. I kind of am making a list here. 3 times 8, and then 4 times 6. Those are all the positive integer combinations that multiply to be 24. And when we factor over the integers. Okay, so how do we know which one to pick? Well, we look at the 10. So we need the two numbers to add to be 10. So you have two things going on. You're looking for a combination, a pair of numbers. One, they have to multiply to be 24, but they have to also add to be 25. So in this first case, those add up to, they have to add to be 10. Okay, so I was looking ahead. In this case, they add to be 25. In this case, they add to be 14. In this case, they add to be 11. I'm getting closer. And in this case, they add to be 10. Okay, so ding, ding, ding. Those are the two numbers. Now, because, and this is kind of a big deal here, because the q squared has a coefficient of 1, notice there's like a 1 here, because it has a leading coefficient of 1 on that q squared, we can just factor, now that we know the two numbers, we can just factor it into the two binomials. So it's going to be q plus 4 and q plus 6. That is a binomial times a binomial. It's correct. I'm going to put a box around it. That's factored. Now, to check it, I use the FOIL. So I go, let me do it underneath here so I don't mess up my answer. So I multiply q times q, I get q squared. I multiply q times 6, I get 6q. I multiply 4 times q, I get 4q. And I multiply 4 times 6, which is 24. And then I have these two middle terms that add up to 10. So that's why it's working. It all checks out. It worked. So q squared plus 10q plus, let me write it, q, I'm going to run into the next problem. Q squared plus 10q plus 24. So that's the check, and it works. Okay? Now, just as a side note, you could write it q plus, oops, not like that. You could write it q plus 6 times q plus 4. I don't really care which binomial you put first. That doesn't matter to me. So the point is it's multiplication. So you have stuff times stuff. And in this case, it's a binomial times a binomial. Okay. Not all trinomials factor that way, but this one does. Okay. So now here we have another example. So we want to look at the last number, 18. We need two numbers that multiply to be 18. And then we want them to add to be -9. So you look at the middle term for the adding part. Okay, so first just think of things that multiply to be 18. Sometimes people see it right off. If you don't see it right off, that's okay. You can make a list. 1 times 18, 2 times 9, 3 times 6. All of those are the different combinations of integers that multiply to be 18. But we have a -9 over here on the, that we want to add up to on the right there. So we need them to both be negative. So you have to think a little bit about when I multiply and I want to get a positive 18, well, they either have to be both positive or both negative. In this case, they're both going to be negative. Otherwise, I can't get my -9. So put these in here. And then which combination is it? Well, it's this one right here. That adds up to -9. So you might have already said that, but good for you. All right, so now that we know the two numbers, we can just simply write the binomials. U minus 3 and U minus 6. And again, you can check it with FOIL. U squared minus 6u minus 3u plus 18. Those add up to the -9u, so it all checks out. Okay,